Hi everyone. My name is Inga Popovaite. I'm a graduate student at University of Iowa, and I study sociology. And and today I'm going to talk about my kind of a backup chapter for my dissertation, which I write about gender and status and leadership and space analogs. And so if you see I'm wearing this very nice uniform, is because just a week ago I was still at the MDRS, and it's very nice for me to see a couple of my crew members here. Hi. Um, but today I'm going to talk about different data than I was collecting there. I will talk, I will give an example how to use crew reports to kind of infer some things about leadership behavior and space analogs. And this is background, this is the outline of my talk, and kind of a couple to notes, why am I doing this? So I started working with secondary data when, even before I was even planning a trip to MDRS myself, but afterwards, I even fell down even more on the secondary data because our trip to MDRS was like postponed again and again and again, and I needed to finish this dissertation somehow, which by the way I'm defending next month. So yay, almost a doctor now. So with that in mind, my talk today was going to kind of a very brief introduction to easy to use computer tools, modeling tools that can make sense of big quantities of text and let us use the data that's already been produced by crew members, and in this way get more information and insights about their behavior without burdening them with additional data collection tools like never-ending surveys or questionnaires and stuff like that. That after my time being there, I see how little time sometimes people have to do that, all the extra data collection. So this is kind of a different way to understand what's happening there without intruding on crew's everyday life. So yes, so today I'll quickly talk about sentiment analysis and structural topic modeling. These are two so-called unsupervised machine learning modeling strategies. By by unsupervised means that the algorithm is already written and you can't tweak it kind of to your ends, but you don't have to use any training data sets or anything like that. It's kind of out of the box tools that you can use yourself. All right, so kind of just because I'm a sociologist, I'm trained to do everything with some data, not just some data, but also theory in the background, meaning that don't look for something where you don't know what you want to find, because you'll just then your results might be just nonsensical. So just to kind of a short theoretical background, what I'm doing, and why I'm doing that. So in this project, I'm looking in particular into communal leadership traits. And what is agentic and communal leadership? This is one of basic kind of poles of leadership behavior that we can think of. There's all the other ones as well, but these are the ones that used quite often in psychology research. So agentic leaders are the leaders who focus mostly on their task accomplishment. So, doers, you have to do this. We need to do this by this specific time. So they focus on task accomplishments. And communal leaders are they a lot of times illustrated as the opposite of agentic leaders. These are the leaders that take their cohesion of the team into account. They're more of a people person, like they would care not only what a task gets done, but who gets to do them, how do they feel doing that, and how does it affect crew morale. So it's very overly simplistic to think about them like one or the opposite of the other, because usually a leader has a combination of two, and but sometimes they kind of lean on one more than on the other. Maybe sometimes they would prefer task over people and the other way around. And the kind of small tidbit from space research, communal traits actually are more important later in long missions. So let's say if a crew stays longer, more than 2 weeks, that you get MDRS, but for longer periods of time, later in the mission, people start caring not about tasks, but about how they feel, about cohesion, about crew morale. And then leader should be more supportive and more crew oriented or more communal to achieve better mission goals. And what we know from research in general, women leaders tend to be more communal in your everyday workspaces. And it stems from a lot of different factors, but one of the main ones, and I'm not going to go into details right now, it's not the focus of this talk, but just social upbringing. Girls that learned and taught from early age that they have to be more friendly with everyone and like take care of each other, take care of, let's say, smallest younger siblings, and so on and so forth. So socially, women tend to be brought up and more communal. However, we don't really know much about women leaders in space analogs or space because there's not enough data, and women are still a minority in both space and space analog participants. So what I'm doing in this project, I to kind of counteract the problem with lack of data. I'm aggregating data from numerous crews, and I'm looking into their reports. And as I said, I'm using a couple of computational methods to make sense of big amounts of textual data. So, okay, so my data, for me, that's the most interesting part. So what I'm using is commanders reports from 2009 to 2016, the season that started 2015. So it is quite a few years of commanders reports. I got them all from the Mars Society website, and code is available by request. Just kind of a footnote, I got permission from James to do that because it's just like a good ethics to even if data is publicly available before you scrape anyone's website, you should at least ask for permission to do that. So I got the permission to do that. And I got over, after I scraped all the data, and then I matched it with report metadata, that is sociodemographic data of the authors. So which I got from their biographies, because every crew has to submit a biography. And after doing all the matching, I ended up with over 800 reports written by 76 commanders in total. And my unit of analysis is a report and not the commander. So here's a quick data summary. So as I said, 824 reports. On average, their length was about 350 words, which is about a page. So that's your standard commander's report. Some of them were shorter, some were very, very long. And about 2/3 of the reports were written by male commanders and 1/3 by female commanders. And the same thing was if we look at split by on an individual level, about 1/3 of all the commanders were women and 2/3 men, which is also, these proportions are on par with actual participation rates of women and men in MDRS simulations, because about 2/3 of all participants are men and a third's woman. So women and men, just kind of to quickly say that men are not more likely to be commanders than women. All right, so sentiment analysis, what is this thing? So sentiment analysis is a quite new algorithm. It's been popular for the last 10, 15 years, maybe 10 years. And it's used a lot in psychology research, consumer research, marketing, political science. The main questions that we ask when we use sentiment analysis is kind of whether this text is more positive or negative. Like, does the user, let's say if it's a restaurant review, do they value it positively or negatively? And that gives you more insight than just like, 5 out of 5 stars rating. So the same in psychology. People look what sort of words do people use and kind of can infer their mood and behavior from that. So the way it's been done, there's a couple of different ways, but this unsupervised way is when you already have a lexicon or a dictionary with words that already has semantic scores attached. That is, what it means that volunteers or human volunteers already were giving a list of these words, and they all attached either positive or a negative score to this. I use Vader, which is a human validated dictionary. It's on par with way more popular Luke, which is used in psychology, but I have to pay for it. And as a grad student, I don't have money to pay for it. So I use Vader, and it's also optimized for shorter text and social media contexts, which was great for me because, as you recall, Commander reports are quite short and free to download and use. And as I said, these dictionaries, they do have positive, negative scores attached to them. So in Vader, the scores can be from -4 for absolutely negative word, and to +4 for very positive word. For example, word friend has an average rating of 2. +2, like +2, and words such as frustrated is -2. So frustrated is a negative word and friend is a positive word. And the way sentiment analysis works, basically you take a text and essentially what you do, you just count how many positive, how many negative words, and you average out the score, and you add, and in this case, you add some more calculations for capital letters and other expressions that are not necessarily verbal, but also expresses positivity and negativity. So I did all that. And here are my basic results. This is all from all Commander's reports. So if you look at that, of all Commander's reports, about 9% of words in each report were positive words, then about 3% were negative words. So reports are very neutral. This is what you would expect because it is kind of professional / technical communication, so you kind of would expect it to be on a neutral scale. And on compound score, which accounts for all positive, negative, and neutral scores, and kind of what is the word? Puts it into between -1, which is very negative, to +1, very positive. Standardizes. Sorry, I forgot that word. So compound score is a standardized score which takes into account all negativity, positivity, and neutrality in the text. And in this case, compound score 0.7 is pretty high. It's closer to 1, which is the absolute positive. So what we can tell about from these numbers that the reports in general were kind of on the more positive scale, but pretty neutral. And so this is the breakdown by gender. This is what I was more interested in. And here you can see this is the overall or compound score. And as I said before, they are kind of reports are pretty positive because if you see, they all clustered closer to 1, which is the absolute positive, right? But then if you see the spread of reports, the black line denotes the median score of the report. These are box plots. So if you see that, if you see women's spread is way thinner around the positive, and men's spread of the reports are they have more variability. And if you do a 2-sample t-test to compare whether there's any statistical significance by gender in positivity of reports, you see that women are statistically significant, more positive in their reports. So that's like small little finding from this part. And then I did some structural topic modeling, which is another computer technique, which in a sense, what it does, a computer or algorithm finds different themes or topics in textual data, and then you can estimate the relationship of these topics to your document metadata, in this case, gender. The metadata is that data that's outside a document that you assign to it, let's say the author's gender, age of a document, and stuff like that. And and here in the bullet points, I put some kind of basic information about this algorithm. So each word in every document has a probability of belonging to a certain topic. And each document consists of a mixture of topics, which makes sense because when we write something, when we write a letter, when we write a report, we don't talk just about one thing, but we usually touch upon different topics or themes. And basically what this algorithm is doing is just seeing which words are more likely to go together, and this is the topic for it. So it's not the topic that as we would understand like coherently as humans, but it's more what an algorithm sees, what is like mathematically which words are closer together. And as I said, we can later use linear regression models to estimate the relationship between metadata and specific topics in your document. Okay, so 824 reports, and my covariate of interest was author's gender. and I selected a model with 15 topics. If we have time if we have time and if you have questions why, I can talk about it. But in general, you can select. It's one of the parameters that you could put on your modeling strategy, whether you want to split text into 15 topics as I did, or would you think that's rather should be just 5 topics or 100 topics. It's up to you. However, my data is relatively small, and 15 topics from preliminary diagnostics were kind of the good fit. And if you're interested, I can later show you how I decided that. Okay, so these are the results. A lot of word salad. What I did here, because I'm interested in communality, remember? So here I just looked whether anything came from the text that was similar to that or at least resembling, because so STM is, I don't want to call it tea leaf reading, but sometimes it almost is. And you have to do, a human has to make a lot of decisions based on what computer gives them. So that's one of the reasons why I like combining qualitative with quantitative work for further validation. So if we look at topic 9 and topic 3, these are the only topics where the words like Mars, Earth, Will Mission, Martian, Space Team, One New Human, and so on came up, or project member, lunch, enjoy. So I selected these, I underlined these topics because they were kind of so different from the other ones, because the other ones mostly talked about tasks like water, experience, engineer, will, tank, hap, clean, emerge, last, and stuff like that. So these were the topics that I could say, okay, this is something communal happening there. So these topics are not just about pure task accomplishment, but it's also about the team, like in kind of humans and life together. So in this particular work, so these topics will represent the communal aspect of commanders' reports. And so the last part that I did, I was like, okay, so I have these communal topics. So let's see whether there's a particular difference between gender, whether women or men are more likely to include these topics in their reports. And then I ran the linear regression. And in this regression, dependent variable is the expected proportion of topic in a document. And my independent variable or predictor was gender. So basically what we see from this table, from regression results, is that on average, sorry, not on average, in reports written by male commanders, they would talk about these kind of communal topics, like topic 3, they would talk about they would allocate about 4% of all text to that topic, or 6% for topic 9. And for women, for both of them, they allocated about 15% of their text to these topics. Again, that would vary like from report to report, but that was the expected proportion of a text allocated to, let's say, these communal topics. So kind of just to sum up this brief experiment with data, what we can learn from secondary stuff is this. So we saw that female commanders' reports, they're more positive than male commanders' reports. And also they're significantly more likely to talk about crews and not just in a task situation, but more about life on Mars. And then the question is, so going back to what I said before, so does it mean that women are better for long-term missions? I wouldn't say particularly yes, but my research does indicate that. However, as I mentioned before, these computer algorithms are not supervised, so you do not train your text, and also they need to be validated, in other words, with different parts of research. And this is what I'm also doing in my dissertation. So yeah, questions, comments, let's talk about computers and how we can study people with them. Thank you.
All right, thank you. Once again, just go ahead and type your questions in the chat. First question is, how does your framework relate to crew resource management team skills in aviation?
Oh, sorry, can you repeat the question?
how does your framework relate to crew resource management team skills in aviation?
So I am not familiar what people are using in aviation, but I can see how this can be useful for that. Let's say if you have pilot like transcripts, like pilot with flight control, you can use those transcripts to see how interactions were happening during the flight, and then you can infer both, not necessarily in this case, maybe not necessarily like leadership skills, but if you can see their positive and negativity, you can totally study that, if that answers at all the question.
Yeah, looks like that was what he's looking for.
Okay.
In regard to the positivity and or the neutrality of the reports, was there any variation in what was considered a successful mission or in the outcomes of these research projects that were happening in each of the missions?
So the short answer is no, and the longer answer is I wish it was. But so what I did, as I say, let me go back to, I don't think I can go back. Oh yeah, I can go back. Let me go back to the description of what Vader is, right? So, sorry. So as I said, it's a already existing lexicon with predefined words. So in total, it had about 9,000 words with assigned scores. So MDRS reports, the same as in general analog research or aviation for that matter, is a very specific, you would call almost subculture with specific terminology that it's usually not included in these generally used like wide usage lexicons. So what is a good, so basically my research could not look into that. If I had more money, or maybe when I have money or research grant, the ideal way to go about it, to collect words and to make your own lexicon that is adapted for specific this context, and then you can actually look into more granular details of positive and negativity in this context. Because now one of the reasons why we see a big, let's say, neutral score is because a lot of words are just not picked up. So a lot of words from these neutral words probably would be like EVA, which is, it's not in the lexicon because it's, most other people wouldn't even know what that is. So it's not assigned either positive or negative score. So so in the future, that's one very good kind of research objective that I have in mind, or someone else can do that too, obviously, is to collect specific words and make a lexicon that's attuned to specific analog context and take more words into consideration.
Another question here. What are some ways that the results could be verified by other methods?
Oh, absolutely. So one way that I'm doing in my dissertation, I'm not talking here now because that would be too long of a presentation. So what I did after I got these reports, and I selected some reports for closer reading for just by myself. And I read about 200 reports like closely and doing the qualitative coding of themes and topics that were emerging. And those results did align with what you see here with STM modeling. Women were more likely to talk about crew, cohesion, mutual support, and men were more focusing on tasks and accomplishments, and also about crew, but from different perspective, kind of working together, but with the emphasis of working and tasks, not together.
Gotcha. Is this something that you think if you had a more specific lexicon that you could determine kind of crew health as a kind of a, the idea of like reading between the lines in the reports and how the crew is going overall?
Yes, absolutely. One of my committee members on my dissertation committee, James Driscoll, he is working on projects like that. They have developed a more complicated and more sophisticated dictionary that captures more emotions, and they are working towards more determining and learning more about how to predict moods and behaviors from reports and transcripts of communication.
Gotcha. Can you explain the parameters or what parameters were significant in the regression table?
Oh, sure. So sorry. Okay, so this is regression table. So the parameters that were significant, it was only one predictor, gender, and that was a significant at p less than 0.001 level. So intercept is, it's not a separate parameter that you usually talk about, but basically the way you would interpret it, so intercept is the value of your dependent variable at this specific instance, the prevalence of a topic, the expected proportion of topic in text. So when gender equals 0 means when it's a male commander, at that point, topic 4, we expect its prevalence at like 4%. But however, when the commander is a woman, gender equals 1. So in that case, the prevalence is 15%, like 0.11 plus 0.4. And these are significant results, yes, statistically significant.
So if you were given the funding that you said mentioned with the grant, how would you evolve this? What would the next steps be for this kind of a study?
So the next steps, I would like to expand my sample size and kind of include more reports. And also, as I said, develop my own lexicon and to pick up more granular differences, and also work more on topic modeling and hire a couple folks to also validated it by qualitative reading it and like tagging the text, because you can also do both of these, like the sentiment analysis and STM can be done as supervised method. However, it involves way more work because you have to train the model. So basically in that case, if I had money and time, I would take part of these texts, tag them all with emotions in one way and or topics in the other way, and then kind of train the algorithm and just test on the other part how it works and how it parses. So
how big of a data set would you need for that kind of training?
Oh, I mean, it depends. So the bigger the better, but yeah, I can't say like exactly, because now I have 800 documents, so that splitting into training and validating is kind of too small. But if I could add another few hundred, that'd probably be okay. Yeah.
Gotcha. So add a few more years of reports, and that would probably give you a good enough sample size.
Yes. However, the thing is that recent commanders reports, they're not mandatory as much anymore. So there's like less and less of them as years goes by. So kind of 2016 was the kind of the last good, kind of was a natural cutoff point, because afterwards it was harder to match them with their biographies, because the way it's like it has to do with the text structure in the website. It just changed the way it's uploaded, and like the way HTML was tagged, and was harder to pick up who's the author automatically. But yeah, it's something also, if I had money and like a couple of undergrads working under me, I could solve those problems, just get everything manually.
Gotcha. All right, well, it's time for the next session. Thank you very much for the presentation and for questions. Once again, just a reminder, this has been recorded, so if you have anything you missed, it will be available on YouTube in the next few weeks.
Yeah.
And with that, we'll see you guys in the next session.
Yeah. Thank you all. Bye.
Take care.
You too.